Okay. Well, hello, everyone, and welcome to the May 2025 edition of the St. Louis Java Users Group. Yeah, I feel like a reporter doing the local TV news or something where they can't get the timing right. But welcome to the group. Next slide, please. For those who don't know, the St. Louis Java Users Group is an informal group. Our first meeting was in May of 1997, so we've been around here for a while. Attendance is free. We have no formal membership list or anything like that. And we try to meet on the second Thursday of every month except December when there's no meeting. There's just too many things going on over the holidays for us to organize a meeting in December. If you're here in person, you can join us for food and social at 6 p.m. and we try to start the presentations here about 6:30. So this live stream and recording is originating, if you'd like to join us in person, from the Object Computing Incorporated training room. We're at 12,140 Woodcrest Executive Drive, Suite 310, and of course that's in St. Louis, Missouri. Next slide. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right here, we have Zach Klein, Ted Doyle,
Yay!
Robert Levitt,
Yay!
Wei-Chi Gao, he's not here today, and me doing the announcements. You can reach all of us on the steering committee by sending an email to that address at the bottom of your screen. That's javasigsc@googlegroups.com. Next slide. The St. Louis Java Users Group would not be possible without the help of our sponsors, and we need more. But we've got Object Computing Incorporated. They've sponsored the lab here where we meet, and also the live streaming capability here through Google Meet. They let us use their system, and they've been with us all along since 1997, and they've bailed us out so many times I can't even begin to count. At the end of this meeting, if you are present to win, either online or in person, we will be raffling 2 Manning ebooks and 2 JetBrains licenses. And so like it says, we are in need of additional sponsors. So you can go ahead, if you know somebody, email us here at the steering committee, javasigsc@googlegroups.com. Next slide. Manning also has for us a 40% off discount code on pretty much any product. So when you go through the store, you just put in JUG 13 when you walk through the checkout for online. Next slide. Okay, the UberConf that is organized by Jay Zimmerman, the same guy who does No Fluff Just Stuff, is organizing his UberConf July 15th through the 18th in Denver, Colorado. And he has given us a discount code as well, Uber25 JUG 2. And if you want more details about that conference, just go to the website that's right there. It's just uberconf.com. Next slide. So if you want to keep up with our presentation schedule, that's easy to do. Just go to our meetup page, meetup.com/JUG. And as we schedule presentations, we post them there on Meetup, and you can RSVP for them there to give yourself a reminder when the meeting starts. I should point out that this is being recorded, and we've been uploading the YouTube videos here. It'll take me, 2 or 3 days, but I'll get it uploaded to YouTube at my YouTube channel, youtube.com/my name, Bruce Alspaugh. So if you're interested in giving a presentation or in sponsoring the JUG, we really would love to hear from you. Like, for example, July is completely open at this point. Just send us an email at javasigsc@googlegroups.com. Next slide. All right, so enough of me. Now for the real reason you came to this meeting. I'm going to turn things over here to our speaker tonight, Jessica Kerr. She's a former steering committee member of the St. Louis Java Users Group, and she's back. Thank you for saving the meeting, and thank you for sponsoring the pizza tonight.
Yeah.
I appreciate it. Yes.
Once in a while, it's great to be in marketing.
Yes, yes, yes. So I'm going to turn off my microphone and I'm going to let you take it away, Jessica.
All right, thank you, Bruce. Okay, my slides are here. Okay, and Ted, is my sound coming through?
Yes.
Great. Okay, I'm here to talk about OpenTelemetry. OpenTelemetry is an open source project all about getting our software to tell us what the heck it's doing, especially in production. And I will have examples in Java today because actually OpenTelemetry works better in Java than any other language. Right, I'm Jessitron. I've been here a long time. I live here, but now I work at Honeycomb.io, and Honeycomb is an observability platform. And this is my first job. I've been speaking at conferences for 12 years, but this is my first job officially in developer relations. So now I manage the DevRel team. There's 3 of us, and we are the engineers in marketing. And we get to explain to engineers how our product works, how they should use it. And a lot of Honeycomb is actually OpenTelemetry, because that's the best way to use Honeycomb, and Honeycomb is the best way to try OpenTelemetry. See, right. So I get to talk about that, and I want to credit Ken Rempel, who's in Philly. He's my team member, and he wrote the examples and some of the slides for this presentation. He's done Java more recently than I have. So, okay, the objective of OpenTelemetry and of Honeycomb is observability, and that means we can tell what's going on in our software in production. I mean, as well as locally, but the hard part is production and the interesting part. And we want to be able to tell what's going on without like shelling into production containers or anything dreadful. We want it to continually tell us what is happening. The word observability has only been in use to describe this since 2016, when Charity Majors, our CTO, dragged it in and tried to define it as something that is, sorry, you can bring a word in, but you don't get to keep it. So observability was brought into software by Charity, who was like, monitoring isn't good enough, I need something else. And the word comes out of rocketry and control theory. And because in rockets, if you have a missile that you fire off and then you report in the news that it went 500 miles an hour and in this direction, and it can change direction so fast and blah, 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 blah. You don't know that because you have like a cop with a radar detector in an airplane up there. You know that because it tells you. And when it tells you, it does that by sending telemetry. It's like transmitting this data back to the launch pad or wherever. And that telemetry is about what's going on. It's about the surrounding conditions. It's about the decisions it's making. Like the wind just shifted to this way, so I'm firing this rocket or whatever. Yeah, so that's telemetry. Telemetry is data that the rocket or the software, well, it's software in the rocket too, sends out just to tell us what's going on. It's not for customers, and we don't need to save it forever, but it does tell us as developers and operators what's happening in that software. And that telemetry comes from code, like everything. And in particular, we call the code whose job it is to emit telemetry instrumentation. And that's like, that word comes from like scientific instruments, because if you think of like, we want to know what's going on inside a cell, we need a microscope. You need a scientific instrument to make measurements to find out what's going on. Bigger, better, or more specific instruments. An instrument might be a marker gene, if you're doing bioengineering. An instrument might be a survey. Social scientists call surveys instruments because they're measurement devices. And this code is instrumentation because it's there to give us measurements of what's happening inside. Now, you already have instrumentation. because every log statement is instrumentation. Every piece of code that emits a metric is instrumentation. And OpenTelemetry is about, yeah, but can we have better instrumentation? Can we do more than just was here? Which is what most of mine say. We've gotten better over the years. You know, we moved to structured logs, and structured logs are better telemetry. We can measure a bunch of things at once from a good structured log. And we've gotten a lot better at doing complicated aggregations with metrics, but we can do better than that. And for that, we need one more concept, because our software, unlike this rocket, is not operating alone. Single programs aren't that interesting. Most of our software systems are a whole bunch of programs. So if you imagine the rocket was like flocking through the sky with a bunch of other ones like birds, and they needed to coordinate because they're not as good at this as birds. When one service here calls into another service, it needs to say why. It needs to give it some tracking information so that we can connect this rocket's telemetry to this one's. When this one told it what to do, what did it do? Include this. Do this as part of this request, and yeah, some ID. And that is called propagation. And that's a new concept that, I mean, we do this already. If you, does anybody send like request IDs through the system? Yeah, and then you put the request ID in the log, and then you can get all the logs for a particular request. That's propagation. Sometimes you do it manually. These we usually do with a header, an HTTP header. And it's a little better if you give it a little bit more information, which we'll talk about. Okay, so instrumentation leads to telemetry, and telemetry leads to understanding. Except the telemetry does not flow directly into our heads. That's not how this works. So we need screens. We need to put the telemetry in a database, and we need to dig around in that database, and we need to like graph things. We need to read the logs, and we need to like look at stuff and click and yeah, because it's in digital space and we are in human space, and we have to have a representation of the telemetry in order to understand it and share it with our friends. Okay, so that's where Honeycomb fits in. This is called a telemetry front end, or sometimes a telemetry back end. Is there a difference? Apparently not anymore. It's actually both, because it's the database and the UI. Anyway, that's where Honeycomb fits in. It's one of many observability platforms. You can also use tools like, you can do open source Grafana or Jaeger for tracing, and you can use Prometheus. Actually, I think Prometheus is backed by another database. It's complicated. But yeah, you can do all open source stuff here if you like pain. But I actually think it's a really good idea. This makes a really good service, because you do not want your telemetry front end to have the same failure causes as your software. So if your stuff is going down, you need this badly. So if you do operate your own, I recommend a network boundary in between. You want these in separate failure zones. Right, so Honeycomb is a service, and we have a really good free tier, so you can use it for free, and I get to talk about it because I brought the pizza. And the free tier is really good. It's like free forever with 20 million events per month, which will get you pretty far in a startup or any side project. Okay, whoops. Right. So that's where Honeycomb fits, but OpenTelemetry is over here. OpenTelemetry is what you put in your software, and OpenTelemetry specifies the format of the data, and it standardizes the format of the data, which is magic. This replaces things like the Datadog agent, also various Prometheus spouters and receivers and things. It replaces, the proprietary agents from Datadog and New Relic and stuff like that. And Honeycomb, we used to have our own libraries that we would encourage you to install to add instrumentation automatically. But we had like 6 because we're a startup, and Datadog has like 800. But OpenTelemetry has hundreds because and a zillion trillion startups. Okay, dozens of startups are now offering telemetry front ends that are dependent on OpenTelemetry, because can't nobody afford to. Datadog has, I heard they have 100 developers on the .NET SDK. Just one of them. That blows my mind. That's twice our company. Amazing. Anyway, OpenTelemetry like puts that all out into the community. And that's really important because not only do you need automatic instrumentation and like exporters and processors and pipelines and APIs and things per language, you need it per web framework, per database client, per all kinds of things. So in your software, when you bring in OpenTelemetry, and Java is super well supported, you can use the Java agent at runtime, and it just like bytecode injects everywhere, and you get really good distributed tracing. But the way it does that is it has an exporter that's just Java. Everything in Java uses the standard OTLP exporter. OTLP is OpenTelemetry Protocol. They just didn't want it to get confused with OTP and Erlang, I think. Right, so this is all in OTLP protocol. And then there's the standard Java SDK, which is like all the parts you need to use OpenTelemetry manually. But then there's automatic instrumentation for Spring and Spring Web MVC and the other Spring thingies and all of these other web servers, web clients, database clients, anywhere that you want to report, hey, something's happening, which is at every network boundary and process boundaries, like between you and the database and stuff like that. You want to report what's going on, and it does that for you, and it handles the propagation for you. So it's intercepting outgoing HTTP requests and shoving a trace ID, which is like a request ID, and a span ID onto the headers. And then on the other end, it's plugged into the web server, and it's pulling those off, and it's continuing that trace. Jim. Right. Right. This is not an agent running on the same box. A Java agent like invades your code at startup. It's bytecode injection. Yeah. And it does things like it accumulates all the telemetry in memory and then sends it in batches. But if you're low on memory, it's going to drop stuff on the floor, because whatever your app is doing is more important than perfect telemetry. There are no delivery guarantees here. It is about real-time insight into what's happening in production, but it's never expecting to be perfect. Yeah. No, not with OpenTelemetry. No. No, that is a different thing. That rocket is making no delivery guarantees about, it's not going to be like, oh my God, I couldn't tell you how fast I'm going. Yes, there are ways to deliberately produce less telemetry. One of the easy ones is, it's called head sampling, is say you get in health requests, you can configure OpenTelemetry in your process to say, actually, probably with environment variables, everything in Java is environment variables, because it doesn't require code changes. I encourage some code changes to add context to these things, but it's all environment variables. Anyway, you can tell it, okay, if it's a health request, don't bother, or a health check. If it's I just am loading the homepage, save 1 out of 1,000 or something like that. So yeah, you can decide how often to produce telemetry, which is interesting. And when you produce telemetry, okay, OpenTelemetry has formats and SDK support and stuff for traces, logs, and metrics, especially traces. I mean, Java, these are all supported. In other languages, traces are first because traces are the hardest to get traces, and we'll look at some in a minute. You have to have propagation, and propagation is really hard to do by yourself. So emitting logs is not hard. If you print a standard out, technically a log. So there's lots of logging frameworks, and they're very independent. And when you make a log statement, boom, you send it to standard out or wherever, and it's gone, and then you're done. And traces require holding things in memory. They require propagating that trace ID and stuff through across execution flows. So if you've got asynchronous execution, Java has thread locals, which help, but then you've got to like follow futures and promises and whatever the heck else is in your library. And then you've got to follow it across network requests. So if you're using gRPC, it goes in the metadata. And in HTTP, it goes in the header. And there's even a W3C standard header for this. It's like a more broad, more universal standard than even OpenTelemetry is. Yeah, so tracing is hard. So that's where OpenTelemetry really concentrates, because implementing distributed tracing, people did it since like 2003 or something. But these people are Uber, and there was one other company that did it, Netflix. We are not Uber and Netflix, but now we can use OpenTelemetry. This is the industry standard. Everybody's moving to it eventually. There's not an excuse not to have great telemetry anymore. Okay, what is great telemetry? Logs, still useful, especially in the front end. That whole hold state in memory and send it to me later thing does not work in the browser. Not well anyway. So logs, they're great sometimes. Metrics, still great for infrastructure. People still use them for applications, but I don't think that's the best. But yeah, sometimes you really do need a time series, because free memory is over time. It's not caused by any one thing. Okay, but I need to show you some traces so you know what I'm talking about, because this is weird. Not everybody knows anything about what distributed traces are. So I'm going to skip. I'll come back to what is OpenTelemetry. Let's go look at a trace. In fact, let's look at the sample app. Okay, nope, this is it. Here's a repo. It is called JUG Hotel Sample. I have forked it from Ken, but it is now in Jusitron, and I have added stupider pictures. And you can run this if you want to. What it does is, yeah, here it is running, I think. And this is a Spring Boot app with two services that don't even talk to each other, sadly. But it also has the client in the browser, which is React. And we can go to our store and we can click shop. And then we get Ken's products. Look how normal they are. And we can add them to the cart. And, oh, this keyboard maybe. Oh, that one got an error. Yeah, that keyboard gets an error. Oh, wait, I'm not supposed to know that yet. Oh, I wonder why we got an error. Speaking of which, well, I'll stuff a load balancer in a minute. Okay, and then Bluetooth speaker is missing its picture. That's a thing. And then you get into my weird pictures. So there's a purse with eyeballs, which my AI has decided is an eye-shaped purse. It's kind of close. Yeah. Oh, look, it decided my prunes were organic. They're not organic. They're from Aldi. There's a cute metronome. I'll put that in the cart. Okay, yes. So then we've got stuff in the cart. We can go to the cart. That's not enough stuff. My new products aren't working. I didn't test the new products. I was just so happy they appeared. Products. What a nice responsive website it has generated. Yeah, the frog, it didn't get to the cart. Well, we'll have to look at what happened when I did that get to the cart. Let's see if we can find a trace for it. Okay. So now I'm in Honeycomb, and I'm looking, what am I looking at? I'm just counting everything right now for the last 10 minutes. We have received 461 metrics. That's bad. That's expensive. 241 trace spans and 1 log. Okay, let me click on this big tall thing. So I'm clicking the graph to go into a trace. It's going to show me one of the traces at that time. Okay. Oh, this is a document load trace. Okay. So this is in the front end e-commerce React app. Oh, that font is little, but the screen is so small. Okay. And the document load, that page took 734 milliseconds to load. And the biggest resource fetch was this one. What was so slow? I don't know, what's this URL? Aha, veet.svg. Rude. Veet, what? Why do I have to have your logo on here? Oh, no, wait, maybe that, no, yeah, it's an SVG. So the page URL was the index and it was loading this. Let me put the HTTP URL in here. There we go. So now we can see, look, the TypeScript only took 275 milliseconds to load. But this trace expresses some sort of unit of work. In this case, it's the document load. And the top span is called the root span because it's the root. I don't know. And every other span is a child span. And this one does not have much of a hierarchy. It just has the document load caused all these things. But you can see they all have durations for how long did they take. And you can find the wide bar to be like, what's the tall pole in the tent that's making everything slow. So that's traces are great for performance optimization. They're not profiling. You do not want every function call in here. If you want to see a 1.5 million span trace, I can go into our production data, but it'll only show 32,000 of them on the screen at once, and it won't be quick. Yeah, so this is a trace, root spans, child span. Let me show you the fields that create that structure. There's a trace ID, a span ID, and a parent ID. Trace dot these things. Okay, so they all have the same trace ID. It's up at the top because this is all part of one trace. This is one unit of work. So this is your request ID. Let me take that one away because it's boring. But the span ID is unique for every single row. So this is just like an ID of a particular log that gets one. And then the interesting one that is distinct with OpenTelemetry is, well, and other distributed tracing tools, is the parent ID. The parent ID is a span ID, but it is not the span. It is the span that caused me. So each of these is like an event, something that happened and how long it took, blah, blah, blah. But they were caused by some other span. In this case, they're all caused by the root span. That document load caused all these things to happen. And that weaves the events into a tree structure. And it's a lot more interesting. Let's see if we can find something interesting in like the back end. So let me look in e-commerce service back end. Has it been more than 10 minutes? Nope, there's stuff going on. Flip over to the traces tab and find an interesting one. This one has 12 spans. We'll look at it. Okay, not super interesting, but at least we have a little bit of structure. Let me color by the parent ID. There we go. And shut up. Okay. So this one's a post. Let's see what it was a post to. That it was a post to API cart items 21. And I wonder from the products page, I wonder which item that was. Interesting. Let me check the service name. Service name says where it came from, like what operating system process it came from. And in this case, we have the React web app talking to the e-commerce service. So traces, it's very important that it's a distributed trace, that this trace ID crosses different services. This particular app, not the most interesting, but we kept it simple on purpose. Later, maybe I'll show you a more complicated one. Right. So 50 milliseconds total. Oh, and this is fun because when you choose to start your traces in the front end, you get an idea of network latency. 50 milliseconds is fast. That's as measured by my browser. Oh, right, because I'm running on localhost. And so half of that was network latency, even locally. I blame Docker. And then most of that was whatever the heck this is doing. I have hidden the name. All right, service name, go away. And then here you can see trace ID, parent ID, or span ID, parent ID, span ID, parent ID, span ID, parent ID. And that's where your structure comes from. Now I can take those away. Pacha, pacha. And now we can see the name. Okay, so, oh, and let me put in the library name, or at least look over here. The library name tells us which instrumentation library created this. So this was made by OpenTelemetry instrumentation fetch, which is a browser library in JavaScript. And then this one was created by Spring Web MVC. So something is plugged into Spring Web MVC to create that. And this one, Spring Boot Auto Configure. Ooh, okay, that's interesting. I think this means we caused it with an environment variable somehow. Or maybe it's from the Spring Boot starter. This one's using the Spring Boot starter instead of the plugin and runtime agent. And then this stuff is coming from JDBC. JDBC, 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 JDBC. So all of these are database operations. That's interesting. So why does it select? Okay, so it selects something in order. What is it doing here? Here's the statement. It's selecting a bunch of stuff from products and cart items. Okay, so it's looking at what's in the cart. It's a post of a product ID, so this should be put it in the cart. And then it does select something from products. And then it does insert into cart. And then it does delete from cart. What is this app doing? And why? Why do we then insert 4 things into the cart on one post? I actually have no idea. Ken wrote this app, and I'm like, what are you doing? But this is a good example of how when you take responsibility for somebody else's code, or code that you wrote 6 months ago and don't remember anymore, and you have to come back to it, the best way to find out what's going on is to get it to tell you, get the app to tell you. And this is, I think, this one called update item quantity. This was specifically configured. Everything else in here is completely automatic. So you stick OpenTelemetry in, it gives you the structure of the trace. You can customize it a little bit. Why does it do 5 inserts? Cart item, cart items, cart items. What kind of stupid table structure is that? Okay. Yeah, so you get an idea, and maybe there's a bug there. Ted.
Yeah, we have a question. Do you
Ooh.
do anything specific to log SQL queries?
It's one of the automatic instrumentations. And I can tell the library name. It's the JDBC automatic instrumentation, which is in the default list. So there's a big list of instrumentations that is going to be like, oh, do you have this library? Bytecode. Oh, are you dependent on this library? Bytecode. So this one was automatic. Yeah, so that's a distributed trace. And this is what OpenTelemetry gives you, is that structure.
So are these statements that are in your code that it's executed in?
Oh yeah. Yeah, I don't know why. But when I look at this statement, delete from carts items. Okay, so I wonder, carts items. Let's look at the code. What the heck is it? Why is it deleting at all? Doesn't find carts items. Oh, you know what I'm going to do? Augment. Okay. I saw, oh, actually a new chat. I saw in the trace that calling, what's this route? API cart items product ID. Why didn't that? Oh, it didn't copy right. Give it to me. Give it to me. Copy. There we go. Results in a delete. Why is that? And oh, and I'm going to change this to chat. Don't go screwing with my code, please. Okay, so we'll ask the AI, and it will probably tell us. Okay, it's looking at this file, update item quantity. Ah, okay, so here is that. Ooh, hold on. There we go. Can y'all see that at all? Oh, good idea. Okay. Command comma, theme. Workbench, color theme, light. Ah, very nice. Good idea. Okay, close that. Cart controller. Oh, that is better. Thank you. Update item quantity. So this with span annotation is added by the Spring Boot starter. If you use just the agent attached at runtime, you actually do have to add a dependency to get this with span attribute. But that's all it takes to create a new span. And then my favorite part, I hardly ever create spans because that makes more events and that makes my trace bigger. And also I get billed per event, or I would if I paid for Honeycomb. But this part, span.current pulls the current span out of thin air, and then set attribute adds more information to the span. And set attribute is the wonderful thing, because now I've set the user ID. I can tell who this problem happened to, if it was an error or slowness or something, or I can tell who is using this feature, who is trying to get this product. Ooh, and we have desired quantity. How do we even get desired quantity? All I have is an add to cart button. Oh, well. And then update quantity in cart. Okay. And the with span attribute just makes this function execute inside a span and then ends the span for you when the function ends. The attributes, if you have per event pricing, which Honeycomb, but also other like I think New Relic prices per event for tracing and stuff, it's common to price per event. So attributes are free, and attributes are free in Honeycomb because they make every piece of data so much more valuable, because now you can correlate users and products and durations and all the other automatic things. Ted, you had your hand up.
Yeah, Gopi in the chat has a question.
Great.
Is there a GitHub project we can clone?
Oh, yes.
Showed at the top there.
There is a GitHub project you can clone if you want to play with this, and it is Jessitron/JUG hotel sample. Thank you, Gopi, for the question. Right. Okay, so we see these attributes getting added to, I like this pull the span out of thin air. This is different from logs. And this is one of the things that is super great about OpenTelemetry, even if you only install it in one service and so you don't get to see all your connections. Because the difference between a span and a log is that a log, you have to accumulate all the information inside your code and then dump it in one place. But a span, you say, okay, I'm about to do something, or you don't. You just let OpenTelemetry automatically create one, which it does. That's usually what I do. And then you say, okay, whatever we're doing right now, hey, we're doing it about this user, and we're doing it for this product, and we're doing it for this quantity. And then later on, oh, and meanwhile, we had this error and stuff like that. And this puts all of that data in one place. So even if all you really want is structured logs, really good structured logs, like a canonical log for the whole request, this gives you that. And it just makes that span available by magic, by bytecode injection and thread local variables and all kinds of confusing things. And you can pull it out and you can put what's important on there whenever you have something to say. So let's see what that data looks like. We had an update item quantity span to look at right here. So if we look at the app dot, desired quantity is 1, product ID is 21, user ID is that string. Yeah, we ran app.jar. Okay. Ooh, I'm going to run the load balancer real quick. Well, I'm going to run it. Where'd load gen go? CD load gen npm run load so that we get more data, not load balancer, load generator. So things will hopefully happen and I'll get more data than I have to make by clicking. Okay, so this stuff happens on here. And the thing about what did I just click? Apparently I clicked look for app.product ID is less than 21. That doesn't make sense. Actually, I'd rather see what different product IDs do we have? And I can, okay, no, don't give me the metrics. We'll get to those later. Signal type does not equal metrics. Okay, that's better. So we had these things happen at all. Most of them have no product ID. Yeah, I don't care about those. Okay, so these 5 products had something happen. Now, it was one of the later ones that didn't work. Did I get any sort of error? No, I didn't. But yet they didn't show up in my cart. Right, where is my cart? Cart, 4 items. Oh, the wide-mouthed frog showed up. Huh. Interesting. If I go back to products and I click on the iPurse, add to cart. Ooh, look, it's being slow. That's a good sign of a problem. Let's look by my session ID. I think this is session ID. And I'm going to find out, do we have a session ID? Whoops. No, I don't know what that's, I don't know what that number is, but I do know how to find out. I will go look at some logs. So for, I'm looking in chat service. That's no use. Session ID equals this thing. Yeah, there's some stuff. What was this? View trace. Okay, here's a get for the product. And I don't know. Where's my product ID? I don't have the product ID. Okay, that's something I should do something about. When you want good observability and you're like, okay, I'm going to implement OpenTelemetry. And if you're in Kubernetes, you can actually install the OpenTelemetry operator and it'll be like sniffing around for Java programs and cramming the agent into them. And poof, you get distributed tracing over your whole system. Try it in development. But then once you get in there, you'll find that you can get really good data about durations and things. Like here's a whole distribution of duration of get products. It's really hard to see. Someday, oh, you know what? I should ask them to make these dots bigger when my font size is bigger, because man, those are some tiny dots. But I can also aggregate, get the P99 of duration there, so I can see how long they take. Last 10 minutes. There we go. Was it right? So I can see normal things, like how slow was it? I can count errors. Does anybody have any errors? No value. None of them have any errors. But the interesting bit is, okay, these ones were slow. Why were they slow? And I can be like, why was it slow? But there's nothing interesting to report. Yeah, they're just these are like it. When I do that, when I draw the box and I say detect anomalies, Honeycomb goes and it looks at all the attributes and it's like, which ones were different between the stuff in the box and the stuff out of the box? Nothing was different because, I mean, I guess user agent.original, but not really very different. The blue bars and the yellow bars are about the same. Yeah, so there's not much. I need to go back as a developer and add a piece of instrumentation that is custom instrumentation. And that's what makes OpenTelemetry really pop. So if I go look for get products, oh, you know, it's probably told me something about that deletion. The update quantity endpoint is defined as this. And when we look at the cart service implementation of update quantity in cart, we see that it has logic to remove an item when the quantity is set to 0. Why would it do that? So when a post is made to product ID with a quantity of 0, the service removes the item from the cart. But it wasn't. The quantity is 1. We saw that in the attributes. But the desired quantity was 1. I can tell from the telemetry. Okay, let it chew on that for a bit. I love live coding with AI because it can actually do it. In this case, I'm just asking it to investigate stuff, but there might be a bug, it says. Yeah, I also think that might be a bug. But I wanted to look at what it was, get API products. So / products, oh, it had API in front of it. What am I in? Request mapping. That's good. Request mapping. That means do the thing. So when I did API products, was it doing this one, do you think? Or was it a particular product? We were looking at API products. That's probably get all. How does that work? Get mapping. Get mapping is going to be just this. So that's a get all products. Okay. Var result equals return result. Let's add a custom field. So span.current .set attribute product count result .size. Done. Let's see if we can import it correctly. That's harder. Okay. So now we can at least get we can get some information in this case. And I love going through and adding these little things. Whenever I have a question that the telemetry won't answer for me, I come to the code and I add one line. And then that makes the telemetry like personalized to my my application. Okay, get all products is kind of boring. But here I'm getting a product by ID, and it would be lovely, boom, to add the product ID. I love autocomplete. Yeah, so we can add the product ID. Oh, and look at this. It's actually, I would like to know whether the product was found. So var result equals return. What do you think? Result, whoops, what did I just hit? Result. And what do you think I want to do here? You're wrong. Oh, okay, no, just span.current.set attribute product found result.get status code is successful. I actually, sure. Now it hates me. What did I do? What did it do?
Oh, you need to.
Oh, there we go. Product does not equal null. That's pretty good. Incompatible types. How did I change result? I didn't change the result. Really? Oh, okay. So it's not smart enough to figure out the super type. Okay, well, it eventually came up with the clever idea of, whoops, put that back in. Okay. It came up with the clever idea of, oh wait, why now? Why do you wait? Oh, okay, 2 semicolons. Get over it. All right. I actually like this better. It's setting the attribute of product exists dependent on whether product is null. Whenever there's a conditional in my code, whenever that's business logic, right? And I'm forking and I'm doing 2 different things, that flags me to set an attribute so that I can tell from the telemetry which path it went down. If it's doing something like super interesting, I'll actually create different spans in the different branches of the if I want to be like, this is a interesting unit of work, and so I'll represent it with a span. But usually I just put something in there so I can tell which path it took. Yeah.
So when you add those attributes, you add whatever you want, you need to be mindful of like personality.
Oh, good question. Okay.
What you think about before you don't everything?
You are limited to strings, numbers, and ordinary things. OpenTelemetry supports arrays. Honeycomb converts them to strings. Sorry. Not objects. So you need primitives roughly. And you don't need to worry about cardinality because this is not a metric and it is not generating a time series. That thing that you added is exactly this many bytes, well, plus the field name, the name and the value. It's that many bytes onto exactly one event. So you're not like creating a place for that field in every event. You're not creating a whole time series for every minute just to say that this 1 minute there was one, which is really nice. And then, oh, let's look at metrics actually. That leads to, in this, if I do a new query and I say all data sets, so everything, and I would like to see whether I'm getting any metrics or logs. And I want signal type. Signal type, meta.signal type is a standard OpenTelemetry field. Just the last 10 minutes, please. Okay, I'm running the load generator. So I'm getting 16,000 metrics in the last 10 minutes. Wow, it's been busy. Of trace spans, I can knock this down to trace.parent ID does not exist. Does not exist. Okay, now I'm counting traces, just the top level, just the root spans. So my load gen has been busy and I've generated 3,500 spans. I have 540 metrics, which is going to be very consistent from 10 minutes to 10 minutes because time series. And I have 19 log statements. That's kind of random. Yeah, just a few little logs, a lot of metrics, a lot of traces. But what's in those metrics? Let's look just at those. Filter to this value. There they are, coming in about 1, 2, 3, 4 per minute. 4 metric arrivals. And if I go over to explore data, then I can see all the different things in there. They're in a data set called unknown metrics because I have not defined the proper environment variable to tell them where to go. But I didn't because let's look at what's coming in the metrics. So we have a host name, nice. A request method in some of them, not all of them. Ted, there's a question?
Yeah, a question from online. Can I access the telemetry data directly from Honeycomb?
Can you access telemetry data directly from Honeycomb?
Directly from Honeycomb, yeah.
Okay, pretty much. This is each row in this. Let me push the maximize space button. Yeah, so each row in here is one piece of telemetry data, one event that's come in. It could be, in this case, it's a metric. So it's like we received some OTLP metrics. We squash them together as much as we can, but it's a metric. It's a time series. It has cardinality problems. Yeah, so you can see the data, all of the different fields in that event in Honeycomb. And I would say that a free Honeycomb account is the easiest way to try OpenTelemetry. It's not, I mean, you're going to have to pay us if you want to use it in production and you're not a startup with no customers yet. But for side projects, it's fantastic. It's a great way to get familiar with OpenTelemetry. And the trick is this Explore Data tab. So after you run any query, oh, which, by the way, I always start with from when I get into Honeycomb, looks like this. It actually probably takes me to some home screen. I hate the home screen. The home screen is bad. Look at it. It says nothing. That's not true. There's a lot of stuff in here. It just, oh, actually there isn't in the chat service. But why did it take me to the chat service? The chat service is useless. Anyway, in a query, I can say all data sets and I can get it all the data. And then I hit run query and then I go to explore data tab and poof, I have everything. I can even make it look like logs with this button. But then that probably needs some fields, but we can add some fields. Not group by this field. I want to add the field. Anyway, this wasn't my metrics. I wanted to look at my metrics. Okay. So we're looking at these metrics over here. Some of them have an HTTP request method. Well, that's weird. Okay, that's a bug. Request method. Oh, table view. Oh man. I have to report this tonight. That should give me a button to say where request method is populated. There we go. Okay, so we can see that we're sometimes get us a 101, sometimes a 200, sometimes a 500. And what? Oh, there's the route. Okay, and so we have all these different routes. And in metrics, you have to get a different event for every one of these. What are we actually tracking in this metric event? Please go away. And what we're tracking is a bunch of duration statistics. What's the longest it took? What's the count of duration? What does that even mean? The sum of the duration and how many of them happened probably. I guess the duration count would be like how many requests did we get to this product ID endpoint in a minute probably. You have to look at how far apart they are to figure out how often. But this is unnecessary. I shouldn't say it's dumb because in some tools it's useful, but I would much rather count how many times we hit this endpoint. So if I filter to HTTP route is this value and I take off the metric thing. Oh, I should leave the trace parent does not exist though. Oh man, it must be a different field name. Okay, but we did, so I'm looking for API cart items product ID. Let me take this condition out. And so I think it probably has a different field name in my traces versus my logs. No, it's HTTP route. And route. Oh man. But my traces should be telling me how, oh yeah, there's a bunch of traces. Oh, no. Okay, so I have failed at finding the right field name. Let me do route contains cart. Nope, that's just the metrics too. Damn it. All data sets. Oh, the route spans are in the front end, and that definitely has a different field name. Okay, so now I see a bunch of traces where the route contains cart. Give me the route. Group by means show me the values. There it is. Filter to this value. That looks the same to me, but apparently I typed it wrong. I don't know. And I can see that there were 314 traces. This is how many times that API was called. And let's see, I only want to see traces. Filter to this value. And I want it to be is root. So that 400 and something must be an accumulating counter, not a just in this last minute. What just happened? What did I just do? I don't know. Hit back. So we've got traces. Oh, dang it. Okay, hold on. The root span does not have the route field in it, but I want to see the root spans and I want to see the duration of the root spans. So now I'm getting complicated. This is a relational query. It's like digging around in the whole trace. Okay, so the route is API cart somewhere in the trace, and it's a trace, and I only want to count the root spans because that gives me the count. There's my 305 in the last 10 minutes. And if I want to know how long those took, I can get this stupid P99 or whatever of duration on demand. And I can get the average and whatever, because this data is already in your traces. OpenTelemetry just by default puts all this data in the traces. It doesn't need to also put it in the metrics so I can store it twice. And the other thing is, when I see the metrics, I can see like, okay, I got so many 101s. Oh, I should group by status too. HTTP status code. Yeah. There's some 200s and some 500s. Okay, what's different about the 500s? Detect anomalies. Okay, what were the 500s? What was different about the 500s? The full URL was different, which includes the item number. This is item 5 that's bad. It's probably that keyboard. And you don't get that from metrics. So metrics can tell you there's a problem, but traces can tell you, no, there was this very specific problem. And then I can limit it to this, show only where field is value. And then I can go look at, I can look at the data, or I can be like, oh, hey, who did that happen to? Do we have user ID in here? Overview. No, we don't have it on that trace. Hold on. Let's try the other span. No, I still don't have the user ID, but I can go dig into one of these traces and I can go look for user ID here and see whether it's anywhere. Update item quantity has it. Okay, so it happened to this user, and I could go find out, now that I know where it is, I could go find out who else it happened to, and I get the trace into what the heck happened. So what was the error? The error was true. What is it? Here's a span event with an exception on it. Bam, something bad happened to our product catalog. Yeah, I bet I could find that in the code. Yeah, so anyway, the metrics are not as good as being able to get the same numbers from your traces. And a lot of tools will let you do some aggregations over traces. They're just like 100 times faster in Honeycomb. Because that's our thing. That's like our big thing. Very fast aggregations over any field in your telemetry. Right, so that's metrics. OpenTelemetry supports metrics. I recommend tracing far more because the metrics do have that cardinality problem. For every new value, you have to pay for a whole time series. And we support metrics, but it's not great yet. We're working on that. Any other questions on this? Or I'll hop back to the slides. Oh, goody. Ronald.
Does this help you find anticipated problems or?
Nope. Nope. Yeah, so the question was, does this help you anticipate problems?
Does it help you find anticipated problems? Like, oh,
Oh.
this or something. Yeah.
Oh, find problems that you anticipated?
What did you kind of expect, or does it just help you find stuff that's totally out of the blue?
I mean, if you know where to look, like for instance, if I think it's going to be a problem when product is null, I'm going to put it in here. Because a lot of the times you're like, should I check for this error? And if you're the AI, you're like, oh my God, I'm going to check for that error 16 different times. But if you're a real programmer made of meat, you'll be like, I don't think this is ever going to happen. And that's a great time to put an attribute on your span telling you whether this ever happened. And then you can go back and find it. Yeah. So yes, you can detect the things that you knew were likely to be problems, and you can go back and ask, is this really a problem? Should I spend time fixing it by how many times it really happened in production?
How would you find stuff that you didn't anticipate?
And then if I didn't anticipate, well, I personally did not anticipate, bam, there's something wrong with the product catalog. But it showed up in the span. So I can go find it in the code. So the distributed tracing is really good for the things that you didn't expect, especially when you can also graph and be like, how many people did this happen to? Does it always happen for this product? And then you can get down to the example that you need. And that often leads you to the code. Dennis.
When you put in the span and the attributes, is there a way to like, I don't know, kind of keep that separate from your logic, your business logic? Because it kind of like
It looks like clutter, right?
Yeah, it is.
Yeah.
I see the value of it, but like an annotation of like some sort of configuration.
If you get super, super complicated with it, you can do it with really nasty environment variables in Java. But I don't recommend that. So 2 points. One, yes, it looks like clutter because it's not business logic, but it does express something. If I look for set attribute, okay, this one might be a little gratuitous because it's a OpenTelemetry sample project. But that's a utility. But this says something about the code that's executing here. It says this matters and this matters. So I don't mind it for that. If you would have log statements, they're just as messy. But I like that I can say this matters right here. However, if user ID is like always something on every request, you want to add user ID and you don't want to duplicate that code, great, make some utilities, make some wrappers, make your own Spring magic thingers. Yeah. I recommend each company, the DevOps or platform or observability or infrastructure teams, if you make any internal libraries or utilities, this is a great thing to put in there. Make your own wrappers and your own little record things that matter functions and put your customer ID and your whatever the heck matters to your business. In this case, it would be product ID, session ID, user ID, that kind of stuff. Put that in everywhere. So yes, abstract it if you can, but also it's expressive. And if you've done that, if you've done the abstraction, so you're always going to get user ID and you're always going to get product ID if they exist. And then you say desired quantity. Desired quantity apparently matters because somehow that's triggering a delete. So then you've got, okay, this particular function, this is what matters. Yeah. Oh, okay. Nice, thanks. And for the camera, there are annotations for method parameters. Nathan.
Can you talk a little bit about PII risks?
Oh.
Information that might escape our system.
Okay. Right. Okay. Also, when your DevOps team is creating the observability helpful things for your product teams, another thing you'll do is run the pipeline. So if you run the Datadog agent, that's sending directly to Datadog typically, and you don't get to look at that data before it leaves your network. Not true with OpenTelemetry. OpenTelemetry, I think there's a really bad architecture slide in this deck. In OpenTelemetry, each of your services is emitting this telemetry, and you configure where it's sent. And Yeah. So this is the stupid way, the like, I'm going to proof of concept. This is running on my box way. The browser app is sending directly to Honeycomb, and then it sends requests like service calls to the service, which in turn sends directly to Honeycomb. So all the telemetry gets there and the traces are connected, but that's not what you do in production. In production, you run OpenTelemetry collector. An OpenTelemetry collector is another big part of the OpenTelemetry project, and this is an executable. It's in Go, I'm sorry, because you will wind up looking at it eventually, because of course it's very configurable and extensible, and you can configure which receivers. So you can use the OpenTelemetry collector to receive OTLP, of course, but you can also scrape Prometheus endpoints. You can slurp logs out of files. You can receive Zipkin and Jaeger formats. This is like the Rosetta Stone of telemetry, because OpenTelemetry has these standardized formats, and it gives you the tools you need to get it from every old format to this. Sometimes that tool involves some really complicated log receiver configuration to turn strings into structured logs, but it's there. So typically you'll send all your telemetry to OpenTelemetry collectors, and then you'll configure your collectors to send to Honeycomb. So your API key is in one place, everybody is sending through there, and in this case, there's in this picture, there's one that exposes an endpoint to receive stuff from the browser, and there's a different one that is, there's probably actually several of these behind a load balancer, receiving from the backend services. And in here, you can do all kinds of processing on your telemetry. A very common one, the Kubernetes processor is like, oh, I know where this message came from. It was this pod on this node, in this container, and it slaps all that information on there, which is really nice. So then you can be like, why is it slow? Oh, it's this pod. And then another thing you can do there is look for PII. So you can check all the strings that come through for something that looks like social security numbers if you want, or addresses, which is stupid. Don't do that. It thinks everything is an address, everything. Also, addresses are not nearly as sensitive, so get over it. Yeah. Okay, that was a bad day. Anyway, you can do all that kind of processing and checking in the collector. Also, you can standardize field names and things like that. Ted?
Question one is there a reporting API for Honeycomb?
Was that a boring API?
A reporting.
A reporting API. Honeycomb has APIs for like setting up stuff and various setting up-y things. It also has a query data API and a service level objective API. Those are enterprise features. So the like Honeycomb, run this query for me and give me the JSON is an enterprise feature. So yes, but not for free. For free, you can run it in the UI, and then you can export as JSON if you really want to. Okay, so good question about the PII. Now let me talk about the collector, which is another major component of the OpenTelemetry project. And that was this slide. So OpenTelemetry is kind of a big deal. It's part of the Cloud Native Compute Foundation. Does anybody know the biggest project in the Cloud Native Compute Foundation? Kubernetes, yes. Except actually by some measurements, OpenTelemetry is now bigger. It's that big. Number of contributors is like the thing it really excels at, because you need contributors who are good at every different language, not just Go. And contributors for like all the different frameworks and database clients and blah, 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 blah. So number of contributors, it exceeds Kubernetes now. But it does a lot of things. It's not like one repo. It's a whole org in GitHub. It's open-telemetry because some mean person wouldn't give them their name. But it's a whole org. The protocols, I think, are the the critical linchpin component because they let people put the telemetry data in a standard format, and all of the vendors accept OpenTelemetry. So Datadog and New Relic and Splunk and all the new startups and Honeycomb. We like jumped on that really early because we don't want to make our own agents. But everybody has come around. Everybody accepts OpenTelemetry. So once you're using that, you can switch vendors. Semantic convention. So like, turns out that what to name these fields is really hard. And you want your http.route to be in the same field name everywhere. And this is the hardest thing to get to 1.0 because, oh my God, the less important it is, the longer people can argue about it. The poor .NET SDK, it's a big deal in .NET that you need to be 1.0 or you're just not safe, is hung up on the stupid, what do I have to name the fields? In semantic conventions that are global projects. They're not language specific. Bike shedding, man. But there are a lot of these. So you like db.statement and all that stuff. I think they recently released one for, was it Redis? Yeah, so they're always updating the semantic standards. The event-driven ones are interesting. And that's useful to us. But also, oh my gosh, there's like a project, it's called Weaver, and its job is to let you define your internal semantic conventions, and then it generates code in all the languages so everybody can import it from a standardized library file in every language that has the same names, and it generates like a whole documentation site. So you can document what these fields mean across the company. People care deeply. I mean, I approve. It's a universal language kind of thing of standardizing on these fields and then making it public and stuff like that. Great deal. Anyway, there's a lot of that. Then there's the API for every language. There's like a API spec for OpenTelemetry in general, and then there's every language's implementation of it, which is some like fitting together of how OpenTelemetry works generally and what makes sense for that language. So in .NET, it's just activity source. A span is an activity because they already have that, and you put an OpenTelemetry exporter for your activity.
So other than JVM languages, which languages do OpenTelemetry or Honeycomb generally work best with?
Honeycomb doesn't care because we're just receiving data. But OpenTelemetry works great with Java, Go, .NET, Ruby. Well, Ruby is a little iffy. Elixir is a little iffy. Rust is painful because Rust is painful, but the support is there. And dozens of other languages. All the major languages. Oh, Python is great. JavaScript is great. What else do we have examples in? I think I named all our example languages. But all the major languages have good OpenTelemetry support. Java's the best. It has the most contributors. There's like hundreds of contributors to the Java SDK. But all the other languages are supported too, to varying degrees. Yeah, I think Erlang is good. Elixir is, but it's also getting better too.
Anything is Prometheus scrapable.
You can convert. Yeah. The collector will just scrape that and turn it into OTLP metrics. And you can even, if you also have like logs and trace spans coming through, you can even put a processor, I think it's called a connector now in the collector that says, take these metrics, put them on the spans. And then you don't have to pay for the metrics. You want to graph memory over time, as long as you have data coming through, you can graph it. And if you don't have any requests coming through, who cares? Yeah. So all the languages and then all the libraries and stuff. And then there's like conventions, and KubeCon is the big one where people talk about OpenTelemetry, but it also has OpenTelemetry Community Day, and there's committees. Oh my God, there's so many committees, and there's meetings every week, and it's very well organized. There's governance and governing bodies and elections. There's elections. So it's a very serious open source project with really good governance, and that's why it's the industry standard. It also gets good support from vendors. We have a whole team that that does a lot of OpenTelemetry work, plus scattered people throughout the company. Yeah, it actually, like, it's a good place because all of industry wants everybody to be able to switch to them. So we all contribute to OpenTelemetry. Honeycomb more than most because we don't have our own agent, but less than the new startups that only support OpenTelemetry. We don't only support OpenTelemetry. You can just send JSON because we're older than that. Yeah, any other questions? Jim? Ooh, goody. Oh, yes. O11Y is, or Ollie is short for observability. I hadn't thought about it for OpenTelemetry. I would have to like capitalize one of the ones to be the L. Yeah, and we have a podcast called OllieCast, O11Y cast. That's Honeycomb's podcast in partnership with HeavyBit. Yeah, that's what I have. Great questions.
2025 I have to ask, so what's the AI?
Oh, okay. So I'm in marketing, so I can talk about this all day. But the philosophical answer is Honeycomb has been very anti-AI for our existence. And it's been really hard to get anyone internally to give a shit at all. I mean, to care at all. But we have come around to be like, no, okay, these tools are important. And they're important in my favorite way is that actually you need observability more because the AI is cranking out code now. You have more code. What is it doing? You know, and you as a developer have to maintain more code. So you need it to tell you what it's doing. And it's easier to get it to tell you what it's doing because I just hit command semicolon and it put the instrumentation in. Yeah, so it's both easier and more important to have observability when you're using AI to write code. And personally, I'm excited because I get to, like, as part of my job, I have to understand how to write code with AI now, so I get to play with it all day. Well, okay, all weekend. But yeah, and other things, like if you have an integration with an LLM, you really need observability. And you really need to not worry about cardinality in that observability. So you really need like the full data of I sent this prompt, I got this back, and I got this prompt from these 16 different data sources. And then in the response that I got back, I reacted in this way and ran these functions and did this next thing. So I think it only makes observability more important and easier. And then we're supposed to do some stuff with AI to like figure out your data or something. There's a team working on that, but our compliance team just will not let them do anything with customer data. They just, So we're working on our terms of service in order to be able to do anything at all with AI to help you look at your data. Yeah, good question. Okay, I put some stickers out. If this is not enough, I have many more stickers. Honeycomb is really good for stickers. So please take some stickers. Thank you.
Okay, well, thank you very much. I think we can end the recording now, and then we will move on to the raffle. So if you can stay online here with us